Hi, my name is Freddie from Zora Data, and today I want to talk about the problem of stitching. So, what is stitching? What are we going to be talking about here? So firstly, I want to explain what stitching is and how it relates to Lineage. Secondly, the value of stitching. So what are the benefits of being able to do this in terms of being able to see the whole picture for metadata. Thirdly, the three types of ways in which you can do stitching. And fourthly, why it's so difficult, not just with those types, but more broadly. This will give a clear picture, therefore, as to what Zora is trying to solve, but also is useful well beyond this product that I'm trying to talk about elsewhere. So let's get into it. What is stitching? So Lineage is the capacity to look through, and if we're dealing with physical lineage here, we're talking about columns, tables, schemas, that kind of level. And it's being able to see from a source point how that information moves through. So here what we see is column A and column B together create column C. And column D is just this individual thing floating within the database. So that's what Lineage is. Stitching is when you have to relate the two from two different databases. So sometimes this is just the extra part of Lineage that is natural, but it's often quite a bit harder to actually do. So as you can see here, it's not just that we need to know about database A and B, we need to be able to see that middle intersection, how the blue leads to green, that dashed arrow. So I want to note as well for the high level that this can be between platforms, this can be between files, databases. It doesn't really matter what the high level elements are. What matters is being able to explain how one of those high level elements leads to the other, but on a granular level. And the reason why it's at the granular level is because normally within a business, that higher level is kind of already understood, right? It's kind of already what people would be able to track and be able to do technical lineage. So stitching is being able to try and find that more detail orientated view and then be able to improve from there. So what is stitching's value? So to me, I think stitching is the last mile, the critical mile of Lineage. And what I mean by that is Lineage, and we'll talk through the benefits in a second, but Lineage is what is so important once you actually have different types of databases that it goes through. Because if you only have a picture of Lineage within a specific spot, that's useful, but probably isn't what you're really trying to track, which is things like how the information moves through the business as a whole, or maybe how it moves through from external sourced information, say a Bloomberg device or something, into how it is then operationalized within the business to make return on investment. So there are three specific benefits of Lineage, and what stitching represents is the detailed view that will then be able to unlock most of those benefits. So the first one is operational efficiency. So this is, imagine you know that there is kind of database A leads to database B and database B leads to C and D, right? You might know that already exists. However, when you actually look at the detailed version of it, it might be that there is an extra area, right? So maybe database A also leads to database F somewhere, right? And that one isn't really used anymore, but kind of just exists within the architecture already. So it's making a whole load of calls and claims, and there's a whole load of database information that just doesn't need to be there anymore. It's just not business relevant. And so being able to view those kind of lineage means that you'll be able to unlock and say, these are easy cost savings that we can make. The second way is data quality remediation. So this is relatively straightforward. If there is a problem downstream of any kind of data quality issue, being able to know where within the data the most likely cause of that problem is really important. If it's a manual input all the way in database A over there, you need to be able to know that that's what's actually occurring once it occurs downstream and is being used within a dashboard and it's clear that the information is faulty. So being able to see the whole picture means that you can quickly work out where the problem is occurring and resolve that problem. And that's obviously important for unlocking business insights and the normal benefits of high quality data for whatever you're trying to achieve. With good data means good information and good decision making, and that's what it improves. The last one I'm putting down is data transparency, but can also be put down as like regulation. So what I mean by this is it's really important under certain contexts to be able to know what your firm is doing and how it's doing it. So if you think in financial regulation, MiFID 2, Solvency 2, Basel 3, that kind of stuff, what we're talking about here is GDPR is quite common as well. What we're talking about here is being able to know what is happening to the information, how is it transforming over time, what is this information doing? And that is what stitching is so critical to be able to unlock, because the biggest changes to that kind of data is probably going to occur at the point that it's moving between the platforms rather than internal to a platform or database. And so that data transparency is really important for being able to guard against regulatory fines, but also being able to prove whatever you're trying to do internally to make sure that you're running cleanly and doing what you're aiming to do to make returns on investment. So there are 3 types, as mentioned in the intro. The first most straightforward type to being able to do stitching is manual. That is, pick up a pen, paper, Excel spreadsheet, input form, and go out and try and find where those connections lie. So this is often find what kind of databases you're looking at, work out the database owners and custodians. So custodians are what we'd just call the particular owners for a database or a platform. Find those individuals, engage them, get them to fill out the relevant forms to give you the kind of information you need to be able to show that stitching. So whatever level of complexity, or if you need to mark certain things as CDEs, that kind of stuff, that's how those forms are filled. You then have to review those forms because not everyone gets it right first time. Normal human error creeps in, as well as a misunderstanding potentially as to what those columns particularly mean. Once that's all confirmed, you ingest it, and so you have a series of large software, or you can just have a series of Excel spreadsheets that highlight how that information is moving between those databases. I think the issues of manual are kind of readily transparent just in the way that I've described it. There are issues of engagement, so you're reliant upon a series of owners and custodians who have other things on their mind because that's probably not their core contractual obligation as to why they're working there. So you need to be able to engage them, to show the benefits of doing it, and to make sure that they're with you on this journey. The second part is just manpower. It requires quite a few people to have lots of conversations in order to get it right and to make sure the information is up to scratch. That means quite a few data governance experts going out into the field in lots of different departments, trying to understand the business context for some of that data sometimes, such that they can capture the right metadata elements. This all takes time, this all takes manpower, this all takes paying someone a wage, lots of cost there. And the third thing, and I think is the critical reason why this is the biggest problem, why I say it scales poorly, is data timeliness. So say you've done that, you've got a team of 10 people, you've gone out to multiple departments, you've managed to stitch together 5 of the critical databases within the area. So you've identified the databases, you've got all the information, you've filled out the forms, etc. The issue is, this is an ongoing process because all of that data will no doubt be changing. If not day to day, it will be changing month to month, and it will certainly be changing over the years as new databases pop up, new data marts pop up, all kinds of different visualization is used. What that means is that even if you manage to get a perfect snapshot, manual has an issue, and that issue is simply put, it won't be able to be relevant as stitching and metadata in potentially a year's time. So you've got to do the whole thing over again. It doesn't scale well. So the second approach to try and automate this as a response to the first problem is similarity search. So imagine you've got the information from both databases, so you can see all the column level, all the table level. You can run a series of different functions that say how similar they are together. Now, there are quite a few different formulas for this. I've used a sort of Levashine equation before in the working context, but I'm sure there are others, and I'm sure you can nuance these kind of algorithms to have more precise claims, perhaps not just on the string title itself, but maybe you could go via individual words, or you might be able to do some kind of pattern recognition for what would be keywords and then be able to extract out those keywords, or even do it via data type. So similarity search doesn't have to just mean what is shown here. It can be done in quite a nuanced way. But there are some serious problems. The first problem kind of will become apparent just from looking at that example, which is customer name and consumer name both have name in them, but lots of things have name in them. So in this example, it might be that the two are correct, and they are actually referring to the same thing, but just via different departments. They're referring to the same clients, same individuals. Or it could be that they are so incredibly different that the idea of connecting the two is total nonsense, right? There's no evidence within the code, there's no evidence within business practice that data is there. So what is used by this algorithm is 74%, but 74% might be really useful or completely wrong. So you don't just have to work out the 0 to 100% and work out what the threshold is of false positives that you can easily get, but you also have to work out the extent to which your data that you're looking at will be able to do it. In practice, what that realistically means isn't just a lot of trial and error, it's a lot of human input. It's a lot of conversation still. It's a lot of ability to do it. And I think the biggest issue with this is it's not trustworthy. In the same way that sometimes we say that we can't really trust LLMs because they hallucinate over certain pieces of information, this will hallucinate. This will give you false positives. So it might be able to match some really obvious, easy ones together. However, it won't show directionality if it's an internal one, and it will have a whole series of issues with that pattern matching. I wanted to note lastly within this slide that machine learning, so reinforcement learning human feedback, helps. So sometimes what you can do is you can look at these examples and you can say, this is correct, this is wrong, this is correct. And you could potentially train not just an algorithm, but some kind of machine learning to solve this more accurately. But this is in practice manual input in the same way that you could say to somebody, I can make a machine that is able to differentiate dogs and cats. But if that machine is just completely fed information via me saying that that's a dog and that's a cat over and over, you're not really solving time, even in the long run, potentially, for the kind of context that we're talking about here. So that kind of human feedback is really useful for when you're designing more general algorithms, but when you're dealing with something as specific as the business context for your firm at that specific moment in time, that kind of thing in practice just looks like manual effort. So the third route, and this is the route that I broadly support, is parsing. So what parsing is you look at the code itself within Snowflake, Databricks, whatever database you're dealing with, and then you try and extract out the metadata from that code. So this can be done via runtime or static. So static is just you take a text file of this code and you're trying to extract out the relevant information. Runtime is you're actually running that code and you're trying to extract the information as that code is run. So if you're making, say, a table call, for instance, a static won't be able to work out all the columns in the table call because it's not seeing it within the code directly. It's just seeing that the table itself is called. But runtime might be able to give that greater detail of information. However, the benefits of static is ease of analysis. You only have to look at the text itself in order to understand it. So you're trying to extract the metadata out automatically. It's highly dependent on code type, and there are quite a few different attempts at solutions for this. But in terms of extracting out the metadata, there doesn't seem to be a sort of one-size-fits-all approach to it. So it's automated, it's scalable because you can run it 100 times, and that's no more effort because it's just simply an algorithm. And it's 100% accurate within the confines of what you're doing once you get the algorithm correct, though it takes time. The issue is it is hard to engineer. And that's the really important part with this, which is type 3 might be the best in theory, but it requires a high degree of data engineering and specificity as to what you're trying to capture and what your success ratio is for trying to capture it. Which is why when you're trying to do a simple automated approach, Elasticsearch or that kind of similarity matching might be really effective. But then when you're moving here, things like parsing can be really useful. So the problem of stitching in more general sense isn't just the limitations that have just been described, but we're dealing with broad and varied systems within any kind of medium to large firm. So often we're dealing with disparate ownership, so lots of different departments with different priorities, plenty of databases that pop up here and there, and then there are limitations within each and every one of the kinds of routes that we're talking about. So manual doesn't have any automated, the other two do. Similarity search has a big problem of false positives that neither of the other two do. And parsing has the problem of just being by far the most difficult solution to engineer successfully, even though it is the most accurate and scalable. So in a sector of data, metadata, data governance has, at least from what I've seen, focused correctly on being able to shift data culture and to make sure people are aware of how they can be effective in the day-to-day, making sure that they're complying with regulations, making sure that they're able to capture all that information. So it's often been seen as very much a people-led approach within data governance, correctly, because you need to get those people on board for it. However, the problem of stitching then arises because there are very few data engineers who are focused within the governance area. It's one of the limitations of it, specifically because the technical area itself is often seen as much more important to focus on pipeline data engineering issues or potentially forms of visualization. So that kind of mismatch often means that stitching itself, whilst it's deemed important and there is funding to try and resolve these kind of issues, often meets a barrier of expertise where the kinds of individuals who are aimed to resolve these places don't. And that's where what my product is steps in. So just in terms of summary then, stitching is a problem. It's the last mile to unlock Lineage, so all those benefits that we listed out of Lineage at the beginning, so operational efficiency, data quality remediation, that kind of stuff. It's hard within an organic architecture of firm because a large firm has lots of different organizations, it changes over time, so it's very hard to be able to get an accurate snapshot even for a moment. There are 3 routes, but each of those routes have their own limitations. And it's best met through automation, but that requires a technical focus that isn't always there. So stitching is critical for Lineage, and yet is very hard to be able to extract and parse out effectively within many contexts. That was the problem of stitching, being able to understand how stitching is the last mile of Lineage. So I've been Freddie, thank you for watching. If you like the video, please like, subscribe. Let me know the kind of experiences and problems that you've had with Lineage or stitching down in the comments below. Thank you very much for watching.